All right, I'm continuing on with experiment or investigation 3B. This is now part 3, screencast. And we're on page 2, down at the towards the bottom where it says mark the equinoxes and solstices. So that's the next thing that we're going to do. I'm going to go ahead and leave my graph up here so that you can see what I'm doing, and I'm going to read along and you guys listen and follow along on your own sheets. It says mark the equinoxes and solstices on figure 1 by drawing vertical lines at approximately March 21st, June 22nd, September 23rd, and December 22nd. Those are the approximate dates for either equinoxes or solstices. So let's take a minute and use a ruler and mark those dates. Remember again that the larger dash indicates the middle of the month. Sorry, I think the larger dash is, let's see, I can't remember. Longer marks represent the first day of the month. Okay, so this would be the 1st of January. Okay. This is the 1st of February, etc. Okay. So where the J is, that's mid-January. Where the F is mid-February, mid-March, etc. Okay. All right, so I'm going to mark my spring equinox for March 21st. And since this mark is going to be the first day of April, that means this is the 15th day of March. And I don't want the 15th day, but I want something kind of between the 15th and the first of the next month. So I'm going to put it right there. Kind of do a dash line. And then up at the top, it's not perfectly straight, but that's okay. At the top, I'm going to put SE for spring equinox. Then I'm going to do June 22nd. That's going to be our summer solstice. So that's mid-March, mid-April, mid-May. Here's the beginning of June. Here's middle of June. So June 22nd is probably going to be in here somewhere. And I'm going to mark SS for summer solstice. Next one they want to do is September 23rd. That is going to be our fall equinox or our autumnal equinox. Here's July. Here's the first day of August. Here's mid-August. Here's the first day of September. Here's mid-September, first day of October. So late September is going to fall in here. And I'm going to put FE for fall equinox. And then I've got one more to mark, and that's December 22nd. That is the winter solstice. And the winter solstice happens right before the end of the year. Okay. And I'm going to mark it over here too. Remember they said that they're going to plot December twice, just so you can see the cycling of everything. Okay. Okay, so we're going to put WS for winter solstice. And we're going to mark it over here too, because remember this is kind of a duplication. Okay. So I'm following along and reading along right here. So we've just marked March 21st, which is our spring equinox. We've marked June 22nd, which is our summer solstice. We've marked September 23rd, which is our fall equinox, and we've marked December 22nd, which is our winter solstice. Okay. On the equinoxes, the noon sun is at some point directly above the equator, whereas on the solstices, the noon sun is at some point directly above either 23.5 degrees north or 23.5 degrees south, depending on who's having summer and who's having winter. Okay? So then it wants you to label the intervals between the lines as the northern hemisphere's winter, spring, summer, and fall seasons. Okay, before we do that, I do want you to go back and highlight that one sentence that said, on the equinoxes, the noon sun at some point is directly above the equator, and at the solstices, the sun is going to be directly above either 23.5 degrees north or 23.5 degrees south, depending on who's having summer and who's having winter. Okay, then it says, label the intervals between the lines for the northern hemisphere, winter, spring, summer, and fall. So let's do that. Okay. Between the winter solstice and the spring equinox is the season of winter. Between the spring equinox and the summer solstice, we're having spring. Between the summer solstice and the fall equinox is summer. And between the fall equinox and the winter solstice is fall or autumn. Okay. And again, this is fall over here too. Okay. All right, so let's answer the questions. We're going to answer 8, 9, 10, 11, 12, and 13. All right, number 8 says 2 maxima and 2 minima would appear in the annual solar radiation curve for the equatorial location if the sky were always clear. Remember, our equatorial location is the red one. As seen from the actual Singapore data, it's evidence that the maxima occur near what? The solstices or the equinoxes. Okay. This obviously is a better example, but you have a maximum right here near the spring equinox. At the fall equinox, it's a little bit bigger than either the summer or the winter solstice. So you're going to have the maximas, the 2 maximums occurring at the equinoxes for Singapore. So that's number 8. Number 9, because the rate of radiation received at Earth's surface is plotted over time in Figure 1, the area enclosed under the curve in each of the seasonal segments is directly proportional to the total solar radiation received during that season. According to the seasonal areas under each curve, which location receives nearly the same total amount of solar radiation every season of the year? Which one varies the least? Which one's flattest? Which one has the area underneath it about the same the whole time? And that's going to be the red for Singapore. That's our equatorial location. If you look at green in the wintertime, here's the area underneath the green graph. And it's much different than the area underneath the green graph in the spring or the summer. Okay? And they're asking on number 9, which location receives nearly the same amount of total solar radiation every season, and that's going to be the red because it's almost a straight line. Number 10, at the mid-latitude location, which is our green line, the seasons of what receive the most solar radiation? So let's look at the green line. We are receiving the most solar radiation during spring and summer, if you'll see that. Okay. For that same mid-latitude location, the seasons of what receive the least solar radiation? Well, if spring and summer are receiving the most solar radiation, that means fall and winter are receiving the least amount of solar radiation. So that's number 11. Number 12, during spring and summer in the northern hemisphere, the South Pole receives how much solar radiation? Here is spring and summer for the South Pole. And if you look over there, that is a big fat 0. The South Pole is receiving 0 solar radiation during spring and summer of the northern hemisphere. Because remember, if we are having spring and summer in the northern hemisphere, then the southern hemisphere is having winter, and the sun is going to stay below the horizon for people at the polar regions. For instance, if you were at the South Pole. Number 13, these are the southern hemisphere's seasons. Well, I just gave it away. These are the southern hemisphere's seasons of, okay, if we're having spring and summer in the northern hemisphere, then in the southern hemisphere they are having fall and winter.